In rectangular coordinates, a point P can be denoted by x and y. This is the x and this is the y, right? But this point we can also use another way to denote the same point P. So let's look at the same point P here. And this point P is determined by the distance between the point P to the origin, r, and the theta it rotates. Right. So this point P can be written as r and theta. So this is called the polar coordinate system. We can use the distance between the P and the origin and the theta, the rotated theta, to denote the point P. So here is r is the distance between P and the origin. So this r is given name which is called the radial coordinate. And theta is called the directed angle between the line segment OP and the positive x-axis. This theta is called angular coordinate. Right? Like the x-y coordinate, we have the x-coordinate, y-coordinate. In the polar coordinate system, we have the radial coordinate and angular coordinate. So here some remarks about the polar coordinates. By convention, the theta is positive if the rotation is counterclockwise. If the rotation is counterclockwise. 2. The polar coordinates of the point P is not unique. Not like the xy coordinates. Every P has only one xy pair, right? But for the polar coordinates, it's not unique. For example, if we have we want to locate 2 and pi over 6. So that means the angle is pi over 6, which is here, right? This is pi over 6. And the distance is 2. So this is this point, right? This is 2. However, we know this angle, if we add 2 pi, right, it will have the coterminal angles, right? The coterminal angle also gives you the same point, right? This is point P. This point P can be written as 2 and pi 6, pi over 6, or you can say, okay, just let 2 pi over 6 plus 2 pi, right? Or you can also write it as 2 pi over 6 minus 2 pi, and so on. So you have many choices of the coordinates. So all these polar coordinates represent the same point P, right? So this tells you that if you have r theta, then the coterminal angles will give you other polar coordinates, and they are all represent the same point. So they are the same thing. Another convention, we also allow r to be negative. But we know that r is the distance, right? It's always be positive. But by the convention, we can allow the r to be negative. So what's the meaning for negative r theta? So negative r theta represents the reflection of r theta about the origin. Okay, so now let's look at this one. If r theta is here, what is negative r theta? Negative r theta is we extend to the other side, reflection about the same length, right? So this is called the negative r theta, and this theta represents this theta, right? Okay, so if we use we can also represent this point by we rotate from here to here, and this is our r. So this point can also be represented by r and theta plus this angle is theta plus pi, right? Theta plus pi. So these two are represent the same thing. R negative r theta, which is the same as r theta plus pi. Okay, so here r is greater than 0. So for example, if we have a negative 4, 2 pi over 3, where is this point? So the first thing we needed to locate 2 pi over 3. 2 pi over 3 is here. Right, 2 pi over 3 is here. This is 2 pi over 3. And here is 4. The distance is 4. So this point is 4, 2 pi over 3. So negative 4, 2 pi over 3, which is this one. This is negative 4, 2 pi over 3. But it also can be written as, we use another color. The angle is this angle, and this would be the distance, right? So it can also be written as, which is 2 pi over 3 plus pi, right? Plus pi, so it would be 5 pi over 3. And the radial coordinate would be 4, positive 4. Okay, if we don't consider the refraction, right? Remark 4. So since the polar coordinates are not unique, so sometimes it's not easy to use, right? So, but if we restrict r to be positive and theta is greater than or equal to 0, less than 2 pi, then the polar coordinates is unique. we only have one representation for the polar coordinate. If we restrict our r to be positive and theta is from 0 to 2 pi. Okay. So now, since the polar coordinate are theta and the rectangular coordinate xy can represent the same point, so there must be some relation between these two coordinates. Okay, so now let's look at the coordinate conversion. So let's derive some formula, right? So this is a x and this is y, right? And here is r and here is theta. So this p can be written as xy or r theta, right? R theta is the polar coordinates, xy is the rectangular coordinates. So if we look at this triangle, this is the right triangle, right? So this triangle tells you that x can be written as, x is the distance, right, from the origin to this point. X can be written as what? R times cosine theta. Y can be written as r times sine theta. So in other words, this is called the polar to rectangular coordinates. This is called polar to rectangular. If we know the polar, we can use this formula to find the rectangular coordinates. What about the rectangular coordinates to the polar? So if we square x, square y, then add them up, then cosine square plus sine square would be equal to 1. So it tells you that r square would be equal to x square plus y square. If we say r is positive, then we just take the square root, right? And if we take the division of these two equations, right, and we notice that the tangent theta is equal to y over x. Okay, so if we know x, y coordinates, we can use this one to find r, and we can use this one, x, y, to find the tangent theta, right? So this is called the rectangular to polar. So some students may ask why we use tangents instead of using the arctangent or tangent inverse of y over x. That will give you an angle, right? But remember, tangent inverse give you angle just from the negative pi over 2 to pi over 2. Yes, so which is in the first and first quadrants, right? So, but our points may be in the second quadrant, maybe in the third quadrant, right? So arctangent cannot cover all the points in the plane. So we use the tangent theta only. Then we need to determine the theta depending on the choice, depending on the problem, right? So now let's look at, if we have the polar coordinates square root 3 and pi over 6, what is the xy coordinate? Okay, so we use x equals r times cosine theta, which is square root 3 times cosine pi over 6. So this is square root 3 times square root 3 over 2. So this is 2 over 3, 3 over 2. And the y is what? R times sine theta. So this is square root 3 times sine pi over 6, which is square root 3 times 1/2, so which is square root 3 over 2. So this x coordinate is 3 over 2 and the square root 3 over 2. We can use this formula, right? So now if we want to convert our -1 and 1, this is the xy coordinate, to polar coordinate. What is the polar coordinates? Okay, and here we know that r squared is equal to x squared plus y squared, right? So it's equal to -1 squared plus 1 squared, which is equal to 2. So if we assume r is positive, so it's r is equal to square root 2. So we have r. What about the theta? And we know that the tangent theta equals what? Y over x, which is -1, right? 1 over -1. However, if we look at the arctangent of -1, tangent inverse or arctangent of -1, which is equal to -pi over 4, right? This one is in the fourth quadrant, but we need our point in -1 and 1 is in the second quadrant, right? In the second quadrant, not in the fourth quadrant. And so we have this -pi of 4 is an angle in the fourth quadrant, and we need an angle theta which is in the second quadrant, but have the same tangent value. So in other words, they should on the same line, right? So this is the -pi over 4. This is the arctangent of -1, right? This is the arctangent of -1. If you just take the tangent inverse, it will give you this angle, but we need in the second quadrant, which is this angle. We need our theta to be this angle, right? Because this is the point, -1 and 1 point. We need this angle. Okay, so how do we get this angle from -pi over 4? Okay, so it's actually this theta is equal to, we just add pi, right? -pi over 4 is on this terminal side. We add pi to get an angle on this terminal side, right? So which is just pi plus tangent inverse of -1. So which is pi plus -pi over 4, which is 3 pi over 4. So our rectangular coordinates for this point is actually square root 2 and 3 pi over 4. Right. Okay, so this is the reason here we use tangent theta y over x, right? Instead of using the arctangent y over x. So you need to locate through the xy coordinate to locate the quadrant. Then we see if the arctangent would be enough to get that angle. If not, we need to use some geometry to add some pi, right, to get the angle we are looking for.